In this video, I'm going to set up the completing the square part, and then you are going to finish the problems for full credit. So let's take a look at what we were just talking about with completing the square. So this, to me, I'm going to try to fit into the du over u squared plus a squared. So always check to see if it is a complete square, then we're good to go, but obviously it's not. So I'm going to rewrite this as an x squared minus 2x plus something, and then I'll put my plus 6 here. Let's complete the square. Half of 2 is 1, squared I get a 1. Remember, we'll do a minus 1. So I get a dx. Let's complete the square. X minus 1 quantity squared plus 5. So I want you to finish off, but let's identify. So u is going to be x minus 1. A is going to be the square root of 5. And then see if you can fit it into your tangent inverse. Number 2, let's do the same kind of thing. So x squared minus 4x plus 7. Half of 4 is 2 squared, I get a 4. So do a minus 4. When I rewrite, I'm going to get u squared plus a squared, and u squared is going to be the quantity x minus 2 squared. So again, I want you to finish it, but let's identify u is equal to x minus 2. A squared is 3, so a would be the square root of 3. Don't forget to du is dx, so I don't need any counterbalancing, and then just use your rule. Number 3 and 4, we have a square root, so we're going to try to fit it into the sine inverse, which, remember, the sine inverse is du over the square root of a squared minus u squared. So when I complete the square here, it's going to look a little different, but I'm going to complete the square on this minus x squared. So remember, when I complete the square, it must be positive. So I'm going to factor out a negative 1 first. So I get an x squared. When I factor out a negative 1, I'll get a negative 6x. So half of 6 is 3 squared, I get a 9. But here I'm really subtracting 9. So then I should add 9 to counterbalance it. Now again, it might not look like it, but what you're going to integrate, 9 is positive, so we have a square root of 9. This is minus 1. Complete the square, x minus 3 quantity squared. Let's identify. A squared is equal to 9. U is equal to x minus 3. And then we can just use our rule for sine inverse. Number 4 is a definite integral, but again, we're going to try to see if we can fit this into a sine inverse, which is an a squared minus u squared. So let's complete the square. When I complete the square on this, I'm going to factor out a negative 1. How do I take half of 3? I get 3 halves. Square it, I get 9 fourths. So when I'm subtracting 9 fourths, to counterbalance it, I have to add 9 fourths. So let me rewrite that as your integral. We're going to put our a squared first, minus our u, almost looks like a perfect a squared minus u squared, which is, again, sine inverse of what? U over a. And again, plus, instead of plus c, now you have to plug in 9 fourths first and subtract off when you stick in 3 halves for x. Okay, so finish that problem up. I'm just trying to set you up before you start some book problems. Number 5, we've got an x to the 4th. This is really going to turn into a dx over u squared plus a squared. Watch how we'll get that. We have x to the 4th minus 4x squared. Let's complete the square here. Completing the square will work on perfect squares. So half of 4 is 2 squared. I get a 4, but I'm really adding 4, so I'll have to subtract off 4. Now, how do I make this quantity squared? This will be x squared minus 2 quantity squared. 9 minus 4 is equal to a positive 5. So this we want to become our du. How can I do that? U is going to equal x squared minus 2. So du is going to be 2x dx. I have an x dx, but I need 2x dx, so I'm going to put a 2 on the inside, and I'll have to 1/2 the outside. So now this looks like a direct tangent inverse. Remember what tangent inverse is? Tangent inverse is 1 over a times tangent inverse of u over a plus c. And in this case, what is u? U is x squared minus 2. So try those, see if you correspond with my answers, and then you'll be ready for some book problems.